Hello everyone. In our last video, we talked about remainders theorem. So this will lead us to factors theorem. What do we mean by factor of a number? Remember that if 2 is a factor of 4, that means that 2 can divide 4 without any remainder. So that's exactly what we mean here by factor theorem. Now, factor theorem states that a polynomial mx plus c is only a factor of another polynomial p of x if and only if the remainder is 0. That is, our p of minus c divided by m is equal to 0. Of course, we know how we get the p, how we get this, that is p of minus c over m. That is when we equate this to 0. When we equate our mx plus c is equal to 0, then we make s the subject of the formula, so we are going to get minus c over m. So anytime that we are given a question, a polynomial divided by another polynomial of lesser degree, when we make the divisor to be equal to, when we equate it to 0, then we make x the subject of the formula. After that, we input our answer into the polynomial and we got 0. That means that that polynomial of lesser degree is a factor of the higher polynomial. Here are some examples. The first question says, show that 2x cubed minus 9x squared minus 6x plus 40 is divisible by x minus 4. Now, what are we going to do here is we are going to equate this to 0, make as the subject of the formula, then the answer the answer that we get, we are going to input it into this polynomial. If our answer is equal to 0, that means this is a factor of this, and if our answer is not equal to 0, that means this is not a factor of this. Now, our divisor is x minus 4, so we equate it to 0. Then we make x the subject of the formula. That means x is equal to 4. Now our p of x, which is the polynomial that we want to divide, or we call it product or dividend, that's 2x raised to the power 3 minus 9x squared minus 6x plus 40. Then, now instead of writing x, we replace it with 4. So we have p of 4 to be equal to 2 into brackets 4 raised to the power 3 minus 9 into brackets 4 raised to the power 2 minus 6 into brackets 4 plus 40. Then our p of 4, this will be equal to 4 raised to the power 3, that's 4 times 4, 16, 16 times 4, 24, 4 remainder 2. That will give us 64. So we have 64 minus 9 into brackets 16, that's 4 raised to the power 2, minus 6 times 4, that will give us 24, plus 40. Now, our p of 4 will be equal to 2 times 64, that will be 128, minus 9 times 16, or we have 16, 9 times 6, that will be 54, so we have 4 in the 5, so we have 144, so we have minus 144 minus 24 plus 40, and this will give us, minus 144 minus 24, that will give us, let's go with the plus first. 128 plus 40, that will give us 168 minus 144 minus 24. So we have 4 plus 4, that will be 8, 6, and 1. So we have 168 minus 168, and that will be equal to 0. So that means since our remainder here is 0, therefore the polynomial, which is x minus 4, is a factor of the higher degree polynomial, that is 2x raised to power 3 minus 9x squared minus 6x plus 40. Yes, so here is the second question. It says, find the value of a, this is a, for which x squared plus 9x plus a is divisible by x plus 5. If a number is divisible by another number, that means that number divides the number without any remainder. So actually what we are being asked to do here is to find the value of a that will make this polynomial divisible by this without any remainder. That is, it will make x plus 5 a factor of this polynomial. So we have, the first thing we do is to equate this to 0. So we have x plus 5 equal to 0. Then we have x is equal to minus 5, where we make x the subject of the formula there. So we input minus 5 for x in the equation. The equation is p of x is equal to x squared plus 9x plus a. So now our p of minus 5 will be equal to minus 5 squared plus 9 into bracket minus 5 plus a. And that will give us minus 5 squared, that will be 25. 9 times minus 5, that will be minus 45 plus a. Then everything here must be equal to 0. Everything here must be equal to 0. So we have 25 minus 45 plus a equal to 0. Now 25 minus 45 is minus 20. So we have minus 20 plus a equal to 0, and we have a to be equal to 20. So when we have our equation to be, actually this is the value of a, therefore the value of a is 20. So what I'm trying to say earlier is that when we have this equation, instead of writing a, if we put 20 there, then definitely this we divide this without any remainder. So we now write our equation as p of x to be equal to x squared plus 9x plus 20. Here's our question number 3. The question says the expression 3x cubed plus kx squared minus 7x minus 2 has 3x plus 1 as a factor. Find the value of the constant k. Now, if this polynomial has this as a factor, then that means when we equate this to 0, we make x the subject of the formula, then the answer we are going to get, if we input it into this equation, then we are going to have 0 as our remainder. So that's exactly what we are going to do. Here's the solution. We equate our divisor to 0. So we have 3x plus 1 equal to 0. Then we make x the subject of the formula. So we have 3x to be equal to minus 1 and we divide both sides by 3. So we have x to be equal to minus 1 over 3. Now, our equation is giving us p of x to be equal to 3x cubed plus ks squared minus 7x minus 2. Therefore, our p of minus 1 over 3 will be equal to 3 into brackets minus 1 over 3 cubed plus k into brackets minus 1 over 3 squared minus 7 into brackets minus 1 over 3 minus 2. So from here we have minus 1 raised to power 3. That will give us, so our p of x will be, p of minus 1 over 3. This will give us minus, here we have 3 first. 3 into brackets minus 1 divided by 3 raised to power 3, that's 27, plus, here we have square. So the reason why we have minus a is here we have cube, so it will return the minus for us, but here we have square. So when we square anything, even if it is negative or positive, our answer will still be positive. So we have 1 square, that will be 1, k into bracket 1 divided by 3 squared, that will be 9, minus, we have minus 7 here multiplied by minus 1 over 3. Minus we multiply minus and we have plus. So we have 7 over 3. Denominator will multiply denominator and denominator will multiply denominator. Here the denominator of 7 is still the same thing as writing, 7 is still the same thing as writing 7 over 1. So 1 multiplied by 3 will still give us 3. And here we have minus 2. So 3 here 1, 3 here 9. So we have minus 1 over 9 plus k times 1 over 9. That will give us k over 9. Of course, how we got that way, I just finished explaining it here. Now we have plus 7 over 3 minus 2. Now, if you could remember, when we have 2 here, we have denominators here, and this is a whole number. We need something to make it, to make it have denominator too, so that we can find the LCM. And remember, writing any number, just write any number. 10 is just 10 over 1. So we put divided by 1 here. It does not change it. 2 divided by 1 is still 2. So another way of writing 2 is writing 2 divided by 1. So we have the LCM of all these numbers is 9. 9 in 9, 1. 1 times minus 1, we have minus 1 plus 9 in 9, 1. 1 times k, we have k plus 3 in 9, 3. 3 times 7, 21 minus 1 in 9. That is 9. 9 times 2, that will be 18. This will be equal to minus 1 plus 21, that will give us 20. 20 minus 18, that will give us 2. So we have k plus 2 divided by 9. Remember, this is our p of minus 1 over 3, and it's still the same thing as the remainder. So we have the remainder to be equal to k plus 2 over 9. But remember, the question says this expression has this as a factor of this. So once it is a factor of this, that means the remainder will be equal to 0. So now we have k plus 2 divided by 9 to be equal to 0. So when we cross multiply, we have k plus 2 to be equal to 0. 9 times 0 will give us 0. Then our k will be equal to minus 2. Therefore, the value of k is minus 2, and that will be our final answer. So that's it on factors theorem. Thank you very much for watching. Remember to like, subscribe, and share to your friends. Thank you.